below the intersecting x-axis are negative. So this would be -1, and then this would be -2. So as I was saying earlier, coordinate geometry helps us identify the position in space of certain objects. So say we have a point somewhere here. Let me use a different color for the points. And maybe another point somewhere here. A point here. And maybe a point somewhere there. Let me make them a bit bigger so that they are visible. My lines are not straight, so you won't be able to see how they are intersecting exactly because it's a rough sketch. So say this is point 1, this is point 2, this is point 3. Well, let me just use numbers. I won't be able to write letters. I wanted to use letters. So this is point 3 and this is point 4. So these points are occupying a certain position in space, and that position can be described using the x and y kind of reference. So let's say point 1 in this case. How do we describe the position of point 1 in this space that's described by these two axes? So let me just indicate this as the y-axis, and then this as the x-axis. So for point 1, as I was saying earlier, you begin with a number that's on the x-axis, the number on which that point coincides, and then you go to the number on the y-axis. So if we were to describe the position of this point here, we'd first scan the x-axis and see where the point lies. So from this, we can see that our point lies just above 4 here, like that. So point 1, the coordinates of point 1, as usual, we write the numbers in parentheses. So point 1 coincides with 4 on the x-axis. So we write a 4 there. And then we separate the numbers with a comma. And then we look at the number that the point coincides with on the y-axis. So you can clearly see that the point here is 2, which is a positive number. So we have our 2 there. So the 4 represents the position on the x, and then the 2 represents the position on the y. And so to describe this position here, point 1 is positioned on the point 4, 2, with reference to the origin, which is here. So if we were to describe this point, we describe it like that. We go to point 2, we do the same, scan the x-axis. We can see here that our point 2 lies just above -1. And when we scan the y-axis, we'll see that it lies, it coincides with +1. So to describe point 2, our point 2 will be -1, 1. We move on to point 3. Point 3, you can see lies just below -3 there on the x-axis, and it lies in the same line. My lines are not straight, but it's supposed to be in the same line with -2 there. So to describe point 3, we have -3, -2. And then point 4, in a similar manner, we scan the x-axis first, we see this lies on 3, and then scan the y-axis, we see this lies on -2. So our point 4 will be 3, -2. So this is the basic idea on how to identify positions in this space that's given by the coordinate system. Some people will call these plotting points, and in most cases you'll be given the coordinates, and then you'll be asked to plot them on the Cartesian plane. So if you're given, say, this point 3,2, and you're asked to plot it on the coordinate system, then where it should lie should be on this position. So you scan the x-axis for where 3 is, so you come to 3 there, and then using the y-axis as your reference, you start going down until you reach the number that's on the right side. So you say positive 3 there, and then you, since our number there is -2, you go to where -2 is, and that is where your point is. So again, if you're given this and you're told to plot this point on the Cartesian plane, you use the same technique. Scan the number on the x. The first number is on the x-axis, the second number is on the y-axis. So you scan the number there, positive, you go to +4, and then +2 again on the y-axis. So you look for +2. So where the two meet like that, that's where your point will lie. So this is how you plot out your points on the coordinate system. Now, having known how to find or describe the positions of something in that space, we have to learn how to find the distance. Say you have one object that's in one position on the graph, and then you have another object that's in a different position. How do you calculate the distance between those two objects using the coordinate system? So this is how you do it. There's an example here. In fact, there are two examples. So there's this example here. You have a point that is called A, and it has those coordinates, or it's being described by these numbers, as we saw earlier. And then we have another point that's B, and it's being described by these. And then there is also this example here. So we're finding the distance between point A and point B in this case, and also point A and point B in this case. So if you can see here, from just looking at the points or the coordinates that are given, you'll notice that what's different is the points or the number that represents a position on the x-axis. If you see, there's 1 there, and then there's 4 there. But for the y-axis, there's 2 and there's 2. This means that these lines, or these points, these 2 points are in the same line, meaning they have the same y value. So as you can see in the diagram here, point A is at a position that's 1 and then 2 units on the y-axis. And then this one is 4 and then 2 units on the y-axis. So they're in the same line. For a situation like this, since the only thing that's changing is the position in the x direction, you just subtract the two x x numbers, so to say. So as we can see here, they are subtracting the initial position. Since we're coming from A, we're going to B. You begin with the number that represents a point where you're going. So you say, or the bigger number in this case. And since positive numbers increase as you go to the right, the bigger number is 4. So we subtract the smaller number from the bigger number, and the difference is 3. So in this case, our distance between these 2 points is just 3 in the x direction. Since nothing is changing in the y, there's no change in the y, so the distance in the y is just 0. And so that is why it's not accounted for. And then for this example, it's similar to the first. The only difference is, in this case, the number that's the same is on the x-axis. So we have 1 there and we have 1 there. But what's changing is on the y-axis. And we can see here again, everything is in a straight line. Using the same method, we subtract the bigger number. We know that going up is positive and going down is negative. And positive numbers increase as you go up, negative numbers decrease as you go down. So in this case, the bigger number between 3 and 2 is 3 and negative 2 is 3. So we subtract the smaller number from the bigger number. And as we can see here, we have 3 minus, then since our number here is negative 2, we have to account for the negatives. And when you do your math here, the negative and the negative multiply, you have a positive. So you have 3 plus 2, which gives us 5. So the distance from A to B is 5. And these examples are tackling situations where your points lie in the same line. So your distance will be just one number because the change is in one direction. There's only one direction. You're changing from one position to the other position along one axis. The other axis is stagnant, it's constant. There's no change in that one. So let me go to my whiteboard again and see if I could come up with some more examples. So this is our origin there. This is our y-axis. This is our x-axis. Then we have 1, 2, 3 on the positive side. Let me just write that already. My 1 looks like a 9. One, 2, and 3. Let me put 3 on the negative also. Negative 1. Negative 2. And negative 3. And then let's have 1, 2, 3 on the y. 1, 2. Okay, there's no space down there. Negative 1, negative 2. 1, 2, 3. So I'm going to put 3 points. So let's say put 1 point there. Another point here. And another one maybe here. And let me even go ahead to describe these points using the coordinates. So this point here is 2, 3. And then this one here is 2, negative 1. And then this one here is negative 2, 1. And then let me name them. Let's say this is A. This is B. And this is C. So if for us to find the distance, say if for us to find the distance, say from point A, let me just put it here, from point A to point B, and let's say the distance between B and C, and the distance between C and A. So let me just leave this example problem here and then go back to notes so that we cover one more concept and then we come and look at those example problems. So from these we see that the 2 points are lying on the same line, meaning one axis. There's no change in distance along one axis. There's only change in distance in one axis. So the first example here, as I was saying, the change is in the x, so there's nothing changing in the y, so you just subtract the corresponding coordinates. So you subtract the x coordinate of b, you subtract the x coordinate of A from the x coordinate of B, and you have your difference here, which is the distance between the 2 points. And the same thing here, where the change is only in the y, the x is constant. You subtract the y component of A from the y component of B. You subtract the smaller one from the bigger one, and then the difference is the distance in between. Now, what happens if the points are not in the same line? So like in this case, or like in the examples that I left on the whiteboard. So you have points that are on a different position in the x and in the y. So you have one that's slightly lower and closer to the y-axis, and there's one that's slightly higher and further away from the x and the y-axis. How do you get the distance in between the two? So from geometry, we know that if we have a right-angled triangle, like the figure that's being made by these 2 points, if we join a line coming downwards and then going this side, we have a triangle. And the distance between these 2 points represents the hypotenuse of that triangle. And from what we know, I believe we all know, there is what's called the Pythagoras theorem, which gives us a way of finding the length of the hypotenuse. The hypotenuse is the longest side of a triangle, a right-angled triangle. So you have this side here, you have that side, and then the longest side. We all know, I believe, the Pythagoras theorem, which says the distance of the hypotenuse, when you square it, is equal to the square of this distance here plus that distance there, which is represented here. Yeah, so there is AB squared, which is the hypotenuse, is the same as the distance from here to there squared plus the distance from here to there squared also. Now, how do we get the distance here and the distance here? That is where our previous example becomes helpful. So we see that if we look at this point here and this imaginary point down there, they lie in the same line. So if we see there's only change in the y-axis, the x-axis is constant. So for us to get the distance from here to there, we just subtract the y coordinates. So if you see there's 4 there, there's 4 there, meaning there's no change in the x. So to get the distance from there to there, we subtract the smaller number from the bigger number. So in this case, we have 6 here, we have 2 there. When we subtract the 2, we have a 4. So 6 minus 2 is equal to 4. So the distance from there to there is a 4. And then if we look at this line here, this point and this imaginary point there, which is point C, they lie in the same line, meaning since the line is horizontal, there is no change in the y, there's only change in the x. So for vertical lines, the change is in the y. For horizontal lines, the change is in the x. So if you see, our x value there and our x value for this point are different, but our y value there and the y value for this point are the same, meaning there's no change in the y. So for us to get the distance here, again, we use the same method, but in this case, we subtract the x coordinates, since that is where the change is. So we say the bigger one, which is 4, minus the smaller one, which is 1, and the difference we get is 3. So the distance from here to there is 3, the distance from there to there is 4. And using Pythagoras' theorem, which says if you get the distance here, you square it, and you get the distance here, you square it, the sum you will get will be equal to the distance here squared. So this is what we have here. So AC is 3, as I was saying, then BC is 4, as I was saying again. And then when we say AB squared, which is the distance we want, is equal to the distance here squared plus the distance there squared. This is 9, this is 16. 9 plus 16 gives us 25. Then since we're looking for the distance AB and not just AB squared, we have to find the square root of AB. So the square root of AB is either -5 or +5. But in this case, since we're dealing with distance, we cannot have a negative distance. Every distance is supposed to be positive. And so we forget about the negative and we maintain our +5. So the distance between this point and that point is 5. So we found this using Pythagoras' theorem, sorry. So having used this example to explain the concept, I'm going to go back to the whiteboard and try and figure out these distances and offer you another opportunity to see how this works. So I'm going to start with AB. Before I do anything, I'm going to draw an imaginary triangle. So the distance we want is this one here. What is the distance between A and B? So to help us visualize this, I'm going to create an imaginary triangle. Use this color. So we have our triangle there, and then let's have our imaginary points somewhere there. So first thing is, we have to find the distance from A to this point. Let me say X for reference purposes. So AX, the distance AX squared plus the distance BX squared, the sum of those two will give us the square of this distance. So now how do we get this distance here and that distance here? So let me just describe this point. This point is 2, 1. So if you can see here, the change is in the x. So we subtract the x coordinates. there's no change in the y, so we only get the x coordinate and the x coordinates. We do our subtraction, that will be our distance. And when we look at point B and point X, we see that there's no change in the x coordinates, but there's change in the y coordinates. So let me just do it somewhere here. You say AX is equal to, so the bigger one between the two is the positive 2 here. Positive 2 is bigger than negative 2, so I'm going to start with positive 2. Since we're subtracting the smaller one from the bigger one, then I say minus, and then this one here, which is negative 2. My 2 looks like a 1. Let me just write it better. So 2 minus negative 2 we do our math here. The negative and the negative, they multiply each other, they give us a positive. We have 2 plus 2, that gives us 4. And then we say bx. So before I even proceed, these were just random points. I'm not sure if the squares will give me perfect squares, but I just put them out to help consolidate the concepts that we just saw in the example. So bx, the x is constant, so the change is in the y. The bigger number is 3, so we have 3. Subtract the smaller number, which is 1, and then our difference is 2. So from this, we see that the distance from there to there is 4, and then the distance from there to there is 2. And since we want to find AB, we have to use Pythagoras' theorem, which says that AB squared is equal to this distance squared plus that distance squared. So AB squared is equal to the distance there squared, which is 4 squared, plus the distance there squared, which is 2 squared. So if we do our math here, 4 squared gives us 16, 2 squared gives us 4, 16 plus 4 gives us 20. So AB squared my writing has become bad. AB squared is equal to 20. And so the distance AB is equal to the square root of 20. If we find the square root on the left side, find the square root on the right side, we have AB is equal to the square root of 20, which should be some number between 4 and 5, I think. So it should be 4 point something. So the distance AB is 4 point something. So this is the procedure. Using the ideas from geometry about the hypotenuse, Pythagoras' theorem, and then using the ideas from algebra where you have square numbers and we have managed to find the distance here through the help of the basic concepts in coordinate geometry. Then our other point is BC? Yeah, BC here. So we found AB. Let me just circle it. We found AB. Let's now find BC. So again, with the aid of a different color, let's get red this time. The distance BC. So luckily, for those that can see already, these two lie in the same line. So there's no much work to do here. So using the technique we used here, we see that the x coordinate is the same. These two lie in the same line. So for us to get the distance between these 2 points, we just subtract the coordinates that are changing, which is the y coordinates. And from what we can see here, we have 3 and -1. So to get the distance between these two, BC is equal to the bigger number, which is 3, minus a smaller number, which is -1. And then here we have a negative and we have a negative inside. The two signs multiply to give us a positive. So we have 3 plus 1, and that gives us 4. So the distance BC is just 4. 4 in the y-axis. Since the change is in the y-axis. So from there we move on to this other point here, the distance CA. So the distance from C to A, what color haven't I used? Let me use green. So this is the distance we're looking for now. And since you're not in the same line, we're going to use the ideas from the right angle triangle and Pythagoras' theorem. So we draw an imaginary triangle, right angle triangle. Just do this. Remove this here. So we go down that way. We put a point there, an imaginary point, and then go this way to a point here. So let me call this point Y, and then let me describe it. So we have -2 there on the x-axis, and then we have -1 on the y-axis. So I'm going to create some space. I'm going to go to a different whiteboard because I'd have to be coming back again. So let me just clear this space here and use it for working out again. Okay, so from Pythagoras' theorem, we have AC squared. I have to write that again. AC squared, I think it looks better, though my C is terrible, is equal to the distance from A to Y, so AY, AY squared plus the distance cy squared. So I'm not going to take much time because I think I've done this several times. So the distance from there to there is 1 minus -1, which is just 2, because you're subtracting a negative number from a positive number. So negative 1 minus -1, the negative and the negative multiply, you have a positive 1 plus 1 gives us 2. So AC squared is equal to 2 squared for the first one. Our AY is 2. And then our CY, what's changing is the X. So we subtract -2 from 2 by subtracting a negative number from a positive number. So you just simply add 2 plus 2, which gives us 4. So 2 squared plus 4 squared, which is almost the same as the one we had. The only thing that has changed here is that the 4 squared is after the 2 squared. So this gives us 20. 2 squared is 4, 4 squared is 16, 4 plus 16 is 20. So AC squared is equal to 20. And then our AC is equal to the square root of 20. So that's how you get distances between 2 points or 2 positions in space. So just to recap, if you're finding the distance between 2 positions,